All right, woohoo, it's normal distributions day. All right, so if you make your histogram and you've got a tremendous amount of data that you've collected, not just 30 shoe sizes or whatever, but a large population, and you make a little histogram for that, your histogram sometimes turns out very symmetric, with most of the data that you've collected being this tall bar in the middle, and then a little less of it, a tallish bar here of the same size, and a little less. And then some of your data really far away from the center. Here's my center, the mean, which is also the median. And then very far away from the mean, I've just got like really short bars. Really short bar there. Really short bar there. If it has this particular shape, and it has to meet some real special criteria that you would get to in both calculus and statistics. But if it ended up looking that way, we would say that our distribution is normally distributed. This funny curve that goes up and down is a normal distribution. Yeah, bell curve is a normal distribution. And this curve has some special qualities to it. It has an inflection point that you probably can't see that's right about here, that if I read down here would be the center. Plus the standard deviation would be right here, and there's an inflection point there, and this would be on the x-axis the center. We'll use the mean minus the standard deviation. Okay. So I think I have another diagram to work through on this. Well, let me just work through this one just a tiny bit more for understanding. So if the center of this was at, let's say, 100, so if the mean of this distribution is 100 and the standard deviation is 10, well, I could mark off 100 plus 10, 110 is about there. Then I go about over here, and here's 120, and a little further on, 130. There is 100 minus the standard deviation, 90. Then I take away another 10, 80, 70. So what it's saying is that the bars over here at 130 are very short. There's very few of those. The frequency is very small. And the bars here at 100 are stacked very high. There's a very large frequency of those at 100. Okay, there's concept. Oh, sorry. So this little place right here on the curve is a point of inflection. It's kind of going downhill, and then it kind of has a point where it's kind of going like that, and kind of going like that, and that's an inflection point. And that is on the horizontal axis. If I read down directly there, that's the mean plus the standard deviation. And on the other side, if I go straight down, if I read straight down, that's the mean minus the standard deviation at the inflection point. You probably don't see that inflection point, but you may when you do calculus or stats. Or you may never. Okay. Things that are normally distributed. Heights. Men's heights have an average of 5'9". There are some people a lot taller than that, and some people a lot shorter. But if you get a lot taller and a lot shorter, you have very few. For women, the center is 5'4". Most women, are around the 5'4" mark, and then there's, if you get, to the 6 foot tall woman, there's not as many of those, or the 4'8" woman, there's not as many of those. Okay, right, 4'8". Oh, okay, 4'8". Okay. SAT scores are normally distributed. They set them up that way. So if the center is always 500, I can't remember what the standard deviation is for SAT scores. I think it's on your homework for tonight. So most people are meant to score around a 500, and then some really smart people get the 600, some really dumb people get the 350, but there's very few of those. Battery life, blood pressure, amount of water in your water bottle. These things have a normal distribution. Manufacturing operations have a normal distribution, and blood pressures have a normal distribution. Most people have a certain blood pressure, and then there's a few people really high, a few people really low. Okay, so normal distributions are all over the place. Okay, so here's my little complicated drawing. So the center of the normal distribution, there's the mean. And here's the mean plus 1 standard deviation. And here's the mean minus 1 standard deviation. And so that would be I'll put the numbers down here, our 100, our 110, 120, 130, 90, 80, 70. And on a normal distribution, 68% of the people in your population of the 68% of the values that you have collected are going to be between the mean minus the standard deviation and the mean plus the standard deviation. So that means, that's this 68%. So 68% of these, whatever, my mean was 100, my standard deviation was 10. I'm thinking IQ scores actually. 68% of these values are between 90 and 110. 95% of the scores collected, the values, are between the mean minus 2 times the standard deviation, the mean plus 2 standard deviations. So that would be between 80 and 120. And 99.7, essentially all of the values in my set are going to be between 100 minus 3 times the standard deviation, 100 minus 3 times 10, 70, and 100 plus 3 times the standard deviation, 100 plus 3 times 10, 130. You have to, you have to know these 68, 95, 99.7. And to figure all that out, to figure all these numbers out, you need to be told what the mean and the standard deviation are in order to make these problems work. Yes, it's always going to be those percents. Those are constants. They're approximate, but they're constants. Scroll up. Yeah. Huh? Oh, you'll have some time tomorrow in class. We'll start some CATSI review, and you'll have project time. sorry, CST review, star review. And we'll have computer lab time on Thursday. And Friday we'll be back in class time and probably just do star review Friday. Minimum day on Monday. Did you guys know it was a minimum day Monday? I don't know what that's about, but we'll be grateful.